Modern passenger vehicles all have sophisticated steering and suspension systems. They're designed to provide the driver with optimum performance, safety and handling. Before committing to a repair, you must understand the basics of these systems. It's no secret that all cars are not created equal in terms of handling characteristics. And by handling, we of course mean cornering. But it's so much more than that. Weight transfer, traction, braking, acceleration and other vital defining traits are heavily influenced by the chassis. OEMs build their cars to a set of numbers, and those numbers often reflect safety concessions, comfort considerations and a variety of others. How a car steers is the first thing most people think about when we mention handling. Some characteristics of a vehicle's steering are locked in. However, other adjustments are widely variable and can be altered by steering alignment. Caster is the angle of the steering axis of a wheel from the vertical, as observed from the side of the vehicle. The forward or rearward tilt results in positive or negative caster. These angles may also be referred to as rake and trail. Generally, caster angles should be equal on both sides, although in some instances, a small difference may be tolerated by the manufacturer for its geographical market and use. A vehicle with a large variation in caster angles between steering wheels will normally drift to the side with less positive caster. The purpose of caster is to provide a degree of self-centering and directional stability for the steering. Too much negative caster can cause instability, particularly at high speed, whilst too much positive caster may make the steering heavy or unresponsive. Caster angles may be affected by worn or loose ball joints, worn control arm bushes, and worn or damaged radius rod bushes. The result of incorrect caster is not normally associated with tyre wear. Most roads that passenger vehicles use aren't flat. They're designed with the crown in the centre that allows rain and flood water to run off the surface. Camber is integrated into the steering system to compensate for the road crown. When viewed from the front of the vehicle, the wheel can be tilted inward or outward from the vertical. An outward tilt produces positive camber, whilst an inward tilt results in negative camber. On most vehicles, camber is an adjustable angle. It can be changed with adjustments to the struts or control arms. These angles are generally set equal on common axles. Again, due to geographical vehicle use, there may be some difference in these angles. The camber angle keeps the tyre face in contact with the road surface during all driving situations. This angle will change with alterations in acceleration, deceleration, braking and vehicle load. A vehicle with excessive camber angle difference on a common axle will have a tendency to pull to the side with the most positive setting and cause uneven wear across the face of the tyre. The vehicle's camber angle may be affected by worn ball joints, control arm bushes, sagged or broken springs, and loose or worn wheel bearings. Toe is the difference measured between the leading and trailing edge of both tyres on a common axle. If the distance measured at the leading edge is less than the trailing edge measurement, the toe is said to be in. If the distance is greater at the leading edge, then the toe is said to be out. Toe is affected by the forces resulting from acceleration and deceleration in respect to the road surface friction. As a vehicle accelerates, the front suspension will lift, the camber angle will change, and the toe will alter. Likewise, these forces will act differently under deceleration or braking, and will affect dissimilar driveline configured vehicles in different ways. In a front-wheel drive vehicle, these forces tend to pull the tyre's leading edge in, so the vehicle manufacturer determines that the initial toe settings be somewhere between 0 and slightly out. Rear-wheel drive vehicles tend to push the front wheels outward as the vehicle accelerates. Again, it's common for the manufacturer to set them with toe in. Toe is determined by the vehicle manufacturers, and ideally it should be a 0 measurement when the vehicle is sitting flat and cruising at highway speeds. These settings allow for minimal friction between the front tyres and the road surface. This is required for optimal fuel economy and tyre wear characteristics. Too much toe-in will push the outer edges of the tyre into the road, resulting in accelerated wear on the contact patch. Conversely, excess toe-out pushes the inner edges of the tyre into the road, resulting in abnormal wear on this part of the tyre. Toe adjustments can be affected by worn steering joints, such as drag links, tyre ends, steering rack bushes, some control arm bushes, and steering rack mounts. Toe is always reflected equally on both sides of the vehicle. If toe is over-adjusted on one side, the steering wheel will be off-centre, and there will be a tendency for the vehicle to pull to that side. Toe is always adjusted from the true centre line of the vehicle. OEMs build a number of preset angles into the vehicle steering system. Most of these can be used for diagnosis. For more information, be sure to watch our other videos in this series. Front setback is a measurement referencing the front wheels to a line placed perpendicular to the vehicle centre line. If a vehicle has setback, one front wheel assembly is farther back from this reference line than the other. Positive setback indicates that the right front wheel is set back further than the left. Negative setback refers to the left front wheel being further back than the right. Front setback can be checked during a normal alignment and is used to diagnose collision damage or cradle misalignment. Excessive setback can cause the vehicle to pull to the side with the setback. A vehicle must be set up so the rear axle follows the front when travelling in a straight line. The geometric centre line must parallel the road direction. This is only the case when the rear axle toe is parallel to this same geometric centre line. If there is a difference, this new line from the rear axle creates an intersection with the true vehicle centre line and produces the thrust angle. When you have a thrust line to the left, it's considered negative, and when it's to the right, it's considered positive. A vehicle with an incorrect thrust angle will tend to pull to the opposite side of the angle. Steering axis inclination is the angle between the centre line of a tyre compared to the centre of the steering pivots. This angle ensures the weight of the vehicle is projected through the tyre to the road. SAI urges the wheels to a straight ahead position after a turn. It does this by inclining the steering axis inward and causes the spindle to rise and fall as the wheels are turned in one direction or the other. Because the wheel cannot be forced into the ground as the spindle travels through its arc, the assembly causes the suspension to be raised. When returning to the centre, the vehicle weight pushes downwards through the spindle to the tyre, forcing the wheels to a neutral position. The vehicle's SAI is a pure diagnostic angle. It can be used to detect damaged or misaligned strut towers, or a shifted cross member, or bent control arms and stub axles. If SAI angles are unequal, it may cause torque and bump steer, or even brake pull. Scrub radius is the distance at which the SAI and centre line of the tyre meet the road surface. Scrub radius is not adjustable or measured, rather it's observed. The line through the steering axis creates a pivot point around which the tyre turns. If the two lines intersect at the road surface, a zero scrub radius would be present. When the intersection is below the surface of the road, it's called positive scrub radius. But when they meet above the road, we call it a negative scrub radius. Vehicles fitted with McPherson struts tend to have negative scrub radius. This assists in counteracting any negative forces created during cornering or acceleration, such as torque steer. We can affect scrub radius during camber adjustments, but the major cause will be experienced if we change wheel offsets, radically adjust suspension heights, or even change tyre sizes. Included angle is not a measured angle, but a calculated angle. If we add the SAI and the camber angle, we end up with the included angle. This angle should be equal on both sides of the vehicle. Incorrect included angles can be indications of a bent steering knuckle or a bent or misaligned strut tower. Toe out on turns, or also known as the Ackermann angle, refers to when a vehicle is turned and the inner front wheel must toe out more than the outer wheel. The inner wheel must do this to avoid scrubbing, but if incorrect, it will affect the steering's return to centre capacity. Toe out on turns is preset within the steering arms of the vehicle. If there is a variance after measuring both sides, an inspection for bent or damaged arms will be needed. Most modern day passenger vehicles now have adjustable rear suspension arms and mounts. Rear toe settings are quite common, whilst there is an emergence of rear camber adjustments available. As with the front, the rear measurements have the same significant impact on the vehicle dynamics and tyre wear. As vehicle suspensions become more sophisticated, similar tests and settings are available for the rear suspension systems. It's important that as techs, we understand the impact of these angles in the vehicle steering geometry. This will promote accurate and efficient diagnosis. Thanks for watching.